the Earth's surface or Earth's gravitational pull is crossed. Okay. If I say there is a minimum velocity required, so this means that until that velocity is achieved, the body will not be able to move away. So escape velocity is basically a velocity which is needed to escape this gravitational pull of Earth. It's like if this is the Earth, body is present and this has to move away till infinity. So this velocity which it is overcoming at this step, this velocity is the escape velocity. Okay, this is the escape velocity. Next is, see, body will stop at infinity. Velocity is 11.2 kilometer per second. Okay. Now, when we are talking about the surface of Earth, mass is present. It is going up. Let's say to some distance. Separation is r and velocity is v. Very easy derivation. From this, at the surface of Earth, the kinetic energy is present half mve square, which gets converted to the potential energy G capital M small m by capital R. Okay. So escape velocity square is equal to 2 capital G by Gm by R. So from here, if you write the formula for escape velocity, it is equal to root 2 capital G capital M by R. So this is the formula of it. But see, sometimes we need to replace things in terms of acceleration due to gravity. Right? So acceleration due to gravity is capital G capital M by R square. So from here, I can say small g into R square is equal to capital G into M. So let's put the value. VE is 2 GM. So that GM can be replaced with, see, what is the formula? 2 GM by R square. R, not R square. If I want, I can replace this formula GM with this. So the formula will be VE is equal to 2G capital R whole square by R under root. R gets cancelled. So one more formula that we have is 2G capital R under root. This is also formula. This is actually the formula of escape velocity, where you know the acceleration due to gravity is put as 9.8. So when you put all the values, you will get the value of escape velocity of Earth. See, if we put everything in this formula, 2 into G is 9.8, into radius of Earth is 6.4 into 10 to the power 6. So when you're putting all these things together, you will get 11.2 kilometer per second. So this value also has to be remembered. Write it. Okay, see, this says that using the concept of escape velocity, calculate the radius of black hole. Please open the cameras, class. Do not shut it. So, see, velocity here, whenever we are studying about black hole, the velocity has to be greater than or equal to the speed of light. This is the whole gist of this question which you have to use. Otherwise, this question is very easy. See, velocity is equal to root gr, and right now the velocity is speed of light. So you can say speed of light is greater than or equal to root 2 gr. Very easy question. This is a very easy question. So c square is greater than or equal to 2 gr. So radius is less than or equal to c square by 2. That's it. One more question we will see. Quickly write this. Okay, see, this question says that a body is projected with a velocity v. It means at the surface of Earth, the velocity is v. And at the surface of Earth, the escape velocity is v. So when you write about the kinetic energy, 1 means the first kinetic energy here, it is half mv square. And when you are talking about the kinetic energy in the second one, means due to this, so it is kinetic energy 2, which is half mve square. So this is change in kinetic energy. Just a second, please. I think the window has. Okay, so this is half mve square. Here velocity is greater than the escape velocity, right? It is given in the question. Let's say this random velocity with which it reaches the position, it's v dash. So half mv dash is equal to the initial energy. And what was the initial kinetic energy difference? This ke, this is the initial kinetic energy difference. So this is half mv square minus half mve square. So from this half m gets cancelled, right? So v square minus ve square is equal to v dash square. So v dash is equal to minus root v square minus ve square. Write it quickly, class. Then we'll start with satellite. Please open the cameras. Alina, Jobita, Jesleen, Ali. Okay, let's start with satellite. So basically, what is meant by a satellite? Satellite is basically one body which revolves around in another body. So the body which is revolving is light in weight, and the body around which it is revolving, it is heavy. Okay. So this is The best example which we have is Earth. So we have satellite. Let's see the definition first. Definition says massive body which revolves around. Yes. Massive body which revolves around a heavy body due to its gravitational pull. So we have two types, natural and artificial. Natural means best example is moon, and artificial in Sat-1. So many satellites are present. Others class, one question on neutral point. So a question can come directly like this. There are two bodies are there and you have to find out the neutral point. So in this has the radius r, this has the radius r, mass m and mass 4m. And the separation is 6r. So let's say that we have taken x separation from this. So this will be obviously 6r minus x, right? So best is if you take the gravitational field in such cases where it is not specified to take what. Why? Reason is that when you are taking gravitational field equal to 0, then you have square in the denominator. So it will help you to get the answer quickly. Otherwise, for potential, it's a scalar. The question will be mentioning things. You have to use what? So I1 is equal to G capital M by X square. And from this side, G 4M by 6R minus X whole square. So G, M gets cancelled. And when you take the root, this is equal to 1 by X is equal to 2 by 6R minus X. So when you cross multiply these, 6R minus X is equal to 2X. Let's shift this X on this side. 6R is equal to 3X. X is equal to 2R. So if X is equal to 2R, so you know now from one side you have 2R separation, from the other side it is 4R. 4R. Though I have drawn it incorrectly. Neutral point, this looks lengthier in my figure, so it is 2R. So when you're drawing, place the neutral somewhere here. Because when the question was there, I didn't know the answer, so that's why I just drew it randomly. All right, anyways, write this down, then we'll start with something else. Launching of satellite and orbital velocity, we have to start. Please write quickly. Let us complete a major chunk so that we are not left with any bits for this chapter. when we're talking about the principle of launching a satellite, this basically means that satellite has to achieve its orbital velocity. So what is this orbital velocity? Basically, we talked about escape velocity, that when the Earth has to cross the gravitational pull of Earth, that barrier, then we had the escape velocity. But when the Earth has to maintain the revolution, not the Earth, any object, any satellite has to maintain the revolution, then we say this is the orbital velocity. So the velocity with which the satellite revolves around is called the orbital velocity. So every satellite revolves around the Earth with this velocity. Pay attention first in the class. So the necessary centripetal force is provided by the gravitational force in this case. Alina, what is the formula of centripetal force? Jyobita? Yes, Jyobita?
V square by R.
Okay, but what was the need for searching this? If you
No,
didn't know
ma'am.
the answer, you could have directly told.
No, ma'am. A message came from my class. That's why.
Mv square by r, yes, Justine, right. Mv not square, here we'll put orbital velocity by small r. So this is capital G, capital M into small m divided by small r square. So the gravitational force is here, the centripetal force is here. Now this r and r square, this is getting cancelled. So V naught is very simple. It is gm by small r, under root gm by small r. Again, we'll replace this with acceleration due to gravity. This is gm by r under root. So now from here, we'll get the value, not under root. This is gm by r square. So we'll put the value of g r square as gm. So now when you put in the values of this, one more thing, we'll write the orbital velocity also as gm by capital R plus h under root. Because small r actually means r plus h. So when you put in the value of gm as g r square by r plus h, this can also be used. One thing, Ali, what is the formula of escape velocity?
Ma'am, I remember the value.
Yes? Yali, what is the formula? That is the formula, that is the value. What is the formula? Root 2 gm by r. And this is root gm by r. So you have a similarity. Escape velocity is root 2 times the orbital velocity. Okay, so this is a similarity which you have to remember. So when we are talking about orbital velocity, the value which you have to remember, this is 9.8 kilometer per second. And when we are talking about the escape velocity, now Ali, which you were saying regarding the escape velocity, which is sorry, not 8, 9.89, it's 8.9. And now, Ali, which you were saying for the escape velocity, it is 11.2 kilometer per second. All right. Write it down, then we'll see a derivation for time period. Okay, class, let us derive the time period. See, time period has the usual formula, speed and distance and time, this relation. So, speed is equal to distance upon time. Distance will be 2 pi r by t. Time period is 2 pi r by v naught. Now, we've already studied that this is root gm by r. So, t is equal to, we'll square this 4 pi square so that we can fit it into the root, right? So 4 pi square r. This is root gm by r. Clear? See, basically I have put the value of v naught as root gm by r. And to get this out of the root, I have to square it inside. That's only I can get 2 pi outside. So what is this equal to? This is equal to 4 pi square r cube, divided by g capital M root. This is our square. So that's why this is our cube. Okay, so see, when we are talking about the time period, let's put this as r plus h. So 4 pi square r plus h whole cube by capital G into capital M under root. So see class, from here we have the formula. What is t square equal to? 4 pi square. This is equal to 4 pi square r plus h whole cube divided by capital G into capital M. Now see class, what is this r plus h whole cube equal to? R plus h whole cube is equal to GMT square by 4 pi square. And what is this? Just r plus h equal to just r plus h is equal to GMT square by 4 pi square. So what is only t square by 4 pi square to the power 1 by 3 minus r. So this is the complete formula for height. Energy, we'll discuss this. First, you write down this derivation of time period. Okay, so when we are talking about the potential energy, so we have studied that gravitational potential energy is G capital M small m by R. So even if you wish, you can use this formula with R plus H. And now we have talked about the velocity, which is under root Gm by small r. So we can write V square as Gm by R. So when we're talking about the kinetic energy we know is half mv square. So which is m by 2 is there, and for v square we have gm by r. So this becomes equal to G capital M small m by 2r. Or what you can do is write capital G capital M small m by 2 into r plus h for small r. Now, when we're talking about this mechanical energy, you have to add the kinetic energy and potential energy. So when you're adding this, means you are adding G capital M small m by 2r and minus G capital M small m by r. So total energy is minus G capital M small m by 2. So this is the mechanical energy. Write it, then we'll start with geostationary satellite. 3 class. Geostationary satellite is basically a satellite that moves with the same speed of Earth. So it appears that it is static. So time period will be 24 hours. And when you put the heights formula, it is 36,000 kilometers. So it is used in radio, TV, weather forecast and all. So a small question can come. And if the height comes, you have to write the same derivation for height. Okay. Write it down. Then we'll start with. Okay, that's why a small portion has been written, Jyotita. Just a small portion, not the entire portion. Just write it. Then I'll start with Kepler's law, last part.